Over the past 2 decades, image-based rendering, or IBR, has emerged as one of the most exciting applications of computer vision. As the progress in the development of IBR, in the near future, there will be more broadcasting videos presented with IBR to enrich the viewing experience. And the TVs will not only display broadcasting videos but also be capable of providing IBR functions. As a result, it becomes a challenge to design a processor embedded in a TV set with low hardware cost and low power consumption. To accomplish it, we introduced the image-based rendering engine. Image-based rendering engine supports several IBR applications, including 2D panorama, concentric mosaics, depth image-based rendering. Our own design Tennis Video 2.0, a novel presentation of tennis video that brings structure, interactivity, and scalability, 3 features to enhance the viewing experience. And Tennis Replay, another application of our own design, an interactive tennis game system constructed with models from real match videos. There are several challenges we'll encounter when building the IBR engine. First is how to integrate various IBR applications with different computations into a uniform architecture. Second, how to overcome heavy rendering time and reach real-time display requirement. Third, how to access reference image or video data rapidly under limited memory bandwidth. Current solutions to this problem may be using CPU or GPU to complete the graphic rendering. However, these 2 solutions are both high cost, so a specific computation unit for video rendering is required. In the design of hardware architecture, 2 major features are introduced. One is the reconfigurable architecture, and the other is the bandwidth reduction. Here is an overview of the proposed IBR engine. It consists of projection engine, prefetch engine, and pixel engine. In the projection engine, we use reconfigurable architecture to integrate different IBR applications. Here shows the utilization of the architecture by different IBR applications. The green lines show the part used by Tennis Video 2.0 and Tennis Replay. The orange lines show the part used by 2D panorama. The blue line shows the part used by concentric mosaics. And the part used by DIBR was highlighted in red lines. Furthermore, to increase hardware utilization, a folding architecture is applied. For a limited bandwidth constraint, we introduced cache mechanism to save the previous data in local buffer and reduce the number of memory access. However, the bandwidth of Tennis Replay is still higher than the upper limitation of the system memory. To solve this problem, a S3 texture compression technique with fixed compression ratio is embedded in our IBR engine. The experimental results are outstanding. Computation performance is 12.7 times higher than Core 2 Duo 2.83 GHz CPU and 2 times higher than NVIDIA GPU. We synthesize our design using TSMC 18 fabrication process and also post it onto FPGA using Xilinx Vertex 5. The proposed hardware has obvious lower cost than CPU and GPUs. In conclusion, we employ the reconfigurable architecture to perform various rendering schemes. We insert cache mechanism to reduce the number of data access and use data compression to decrease the size of data transmission. And, to the best of our knowledge, this is the first processor specific for image-based rendering, which provides higher performance but uses less cost than CPUs and GPUs.